So here is my final type of example. Now it's still a quadratic because we've got something squared and we have another term here, so it's still kind of quadratic, but this one always throws people off a wee bit, and it's going to be important later on in the task 2 type of equations that we're going to look at. Again though, we can rewrite it with kind of y's instead of cos x's. It just helps us see it. You might get really used to this and be able to do it without writing it in y's, this one. But again, it helps us kind of see what's going on and get a feel for it. We've got 2 terms in our quadratic this time. You could do a full factorization, but it's quicker to spot. You can take a y outside of a bracket here. So you can take y out of both of these terms, and it would leave you with 5y minus 1. And there's our factorization. So it's a wee bit different because it's just a letter at the front of a single bracket, but otherwise kind of similar method. Let's apply that to our cos equation. Well, instead of a y coming outside over here, that's a cos. So we're taking a cos x outside, and that leaves us with 5 cos x, take away 1 inside the bracket. 2 things multiply together to give us 0. So either, in that case, cos of x equals 0, or 5 cos x minus 1 equals 0. So that gives us 2 things to go away and solve that will give us our answers. Let's deal with cos x equals 0 first. Again, if you ever get cos or sine equal to 0, 1, or minus 1, I would highly recommend just diving straight into a graph. It's just a bit easier to see. Now, this is where it's important to note our range. What range are we solving in? Well, 0 to 2 pi. So we're working in radians here. There's our 2 pi. There's pi. Where are we? 0 or 0 there and there. You might scratch your head for a second with this, but that's 90 degrees. It's halfway to 180, so that is pi over 2, and 270 degrees, which you hopefully start remembering, is 3 pi over 2. So there we've got 2 solutions to our equation in radians. So we've got pi over 2 and 3 pi over 2. Moving on to our second half, that's this one. We've got 5 cos x equals 1. And so cos x equals a fifth. Now, it doesn't matter which method we're using. We're going to do x equals cos to the minus 1 of a fifth and find out what that gives us. And remember to put your calculator in radians mode. It's going to give us that. And let's round that to 1.37. And I'm going to put a little rad there. I didn't put it over here because we had everything in pies. Less obvious when you got a decimal, but just to remind us, this is radians. Now, because we're working with a positive 1, that is also a relative acute angle that we're working with. And so that's one of our answers. Draw ourselves a graph. A nice little cos graph. Somewhere over here. So that is 1.37 radians along. Matching bit of the graph is that bit. Here's our 2 pi along here. That's pi in the middle. So we can see coming along by 1.37 radians is the same as coming back from 2 pi. So we want 2 pi, take away 1.37, and we'll work out what that gives us. But using cast, well, we had a cosine and it was positive, so it's either there or there. That's 2 pi, so this section is 2 pi minus the relative acute angle. Gives us the same thing. So, doesn't matter which way you've gone about it, you'll get that. And that should, if you work it out, give you 4.9137469. That rounds nicely to 4.91. And again, I'll just put a little rad to remind us we're working in radians here, although it's strictly not 100% necessary. Always good. Let's list our answers. So our answers were pi over 2, 3 pi over 2, 1.37, and 4.91. And they're all in radians. Good. So there we've got another solution. I would like you to try something very similar. Classic little your turn. So there is one for you to try. So pause the video and I will run through that in 1 or 2 minutes. Okay, so hopefully you paused and you've had a go. Let's look at our solution. So I've put it into algebra here. So I've changed signs to y's. So that's 3y squared take away 2y equals 0. I've factorized out a y. And that's giving me this factorized form, which I've translated back into signs. So there's sine x in front of our bracket, 3 sine x, take away 2 inside our bracket. That either means that sine of x is equal to 0, or the bit in the bracket equals 0. Solving sine x equal to 0, I've just sketched the graph. Now this is super important to note, and I didn't really make a big thing of this before, but here I've got less than or equal to and less than or equal to. That's super important, because if this was just a less than sign, you wouldn't get this point. But in this case, I've included both the endpoints. So we're including 0 and pi and 2 pi. So all 3 of those are possible places where the sine x curve equals 0. On the other side, solving 3 sine x minus 2 equals 0. Well, I've divided both sides by 3. I've gone ahead and solved that to get 0.73 radians. And then I've done my graph and found the other angles. So very standard procedure over here. I'm not spending a lot of time on that. Standard procedure that we've kind of got used to. That should have given us 4 answers at the end. Oh, sorry, 5 answers. 0, pi, 2 pi, 0.73 radians, and 2.41 radians. So hopefully that matches with what you got. If not, just take another look and see if you can spot what's different. Great, there's a lot there, but they are all building on this technique of solving a trig equation here by just doing a little bit of factorizing or rearranging to start with. Have a go and ask on the channel if there's anything we can help with.